Here we've just been given the pictures of f of x and g of x. So f of x has a restriction that x must be greater than or equal to 0, and g of x has a restriction that x cannot equal positive 3. So when we combine these, whether it be addition or multiplication, this is going to end up giving us a domain of x is greater than or equal to 0 and x is not equal to 3. Now it's kind of hard to predict what this is going to look like, but if we were to think of what this looks like, we're multiplying a reciprocal function with a square root function, so it ends up being kind of a square root with a reciprocal function or a denominator on the bottom. Now, we're not going to be expected to do a lot of analysis of what these graphs are going to look like, but we should start thinking about these things and developing some skills in how to analyze this. So this equation here, the q of x, is going to be given by the f of x over the g of x. So we're going to write this equation explicitly. So q of x is equal to, I'm just going to substitute the f in the numerator and the g in the denominator. And what ends up happening is we end up getting a function that is recognizable, something that we've actually dealt with before. So this is one of the strategies we want to use. If we can combine it explicitly and simplify into something that we recognize, then we know how to graph this function. Because we know that this function has zeros at x equals 5. Okay, from the numerator, we know that it has a 0 at x equals 5. We know that it has a vertical asymptote. And that vertical asymptote occurs at x equals negative 2.5. Okay, so I have vertical asymptote here. I also know that it has a horizontal asymptote because if I take the limit as x goes to infinity, well, we know that the numerator and denominator have the same power or same degree. So the horizontal asymptote is just a ratio of the highest power x's. So it's going to be at 1/2. So I'm going to have some horizontal asymptote here. I know my graph. I can also, substitute an x to 0 to get a y-intercept. But I know my graph's going to look something like this. Follow the asymptotes here, and it's going to follow the asymptotes here. And again, if you want more detail, we can actually start making a table of values for this.